Hi there, this is Jacob Nash, Precalculus Lessons, and this is Unit 2, Lesson 1 on exponential function basics. So, on these first few lessons, I can't have the intro, and I kind of have to be a little bit quieter right now, but that's fine. So, that's why that's like that today. But, you learned what exponential functions were when you were in Algebra 2, hopefully. So this is kind of just a review, but there are a few new things that we'll learn. So the general form of an exponential function is f of x equals a times b to the x. Sometimes you can see this too, y equals 2 to the x, but that would just be assuming that it had a base of 2, and a and b can be any number, but let's figure out what it means. So a is the stretch or compression, so it affects how the graph is shaped, but also it is the y-intercept. Now, keep in mind that it's only the y-intercept if there's no transformations, and we'll talk about that a little bit in the next video when we graph them. But that's not always the case, but in the case of this equation, if it's a times b, really a is 1, so it's 1 times 2 to the x, so the y-intercept is 0, 1 for that function. But if you had like a plus 1 right there or something, that doesn't work. Then it changes a little bit. So b is the base, and if the base is greater than 1, then the graph is growing. It's a growth factor, or not growth factor, it's just growing, and there's decay if it's between 0 and 1. And if it's negative, then that just would mean there's a reflection. So when a graph is growing, it looks like that, but when it's decaying, it looks like that. And that makes sense. If something's going up when it's growing, it's going down if it's decaying. But here's some things that can never happen. I didn't mean to say b can't be negative. I didn't mean to say that. B can't be negative. A can. That would be if there was a reflection. But once again, we'll talk about that in lesson 2. A and b can't be 0, b can't be 1, and b can't be negative. So let's look at a couple examples here. Name the y-intercept and base. Okay, let's look at one. So I said that the y-intercept is a. In this case, that's true, but not if there was transformations. But there's not. As you see, there's x, x, and x. Well, negative x on a third, but we'll get to that. And then the base. So this one, 7. Since we only see 7 there, not two numbers, it's really 1 times 7 to the x. The first number is the base, which is the y-intercept. So the y-intercept is 0, 1 because of that 1. And then the base is 7. That's simple. Okay, the next one, the y-intercept is 0, 2, and the base is 3. And those are both growth ones, because it's 3 and 7 are greater than 1. This one, there technically is a transformation. This really would mean that there's a base of 1/4, and then that would mean there's a horizontal reflection, which would really mean that it would look like basically, if you have, since there's a 1/4 base, that means it's decay. But because of this, that means there's a reflection. So instead, it's like that. So it actually is growing anyways. But another way to look at it is, since this is negative, when you have a negative exponent, you can instead flip the fraction to 4 and then make it an x. That looks a little bit better, and that's what it actually is. So these two things are the same. This one appears to be a decay, which it would be, but because of that negative, it makes it like that. And this one we just know is like that. Okay. And so that would mean that there's really a 1 here. And so y-intercept 0, 1, and then base is 4. So, pretty simple. That will be it for this video. I'll see you on the next one. Thanks for watching.